Hello everyone, welcome to my YouTube channel. Today we have another video for supports and reaction and how to replace every support that we can find in equilibrium and non-equilibrium equations with its reaction when you draw the free body diagram. Last video was all about the free body diagram, so if you didn't watch the video, last video, I suggest that you watch it before this one so you'll be familiar with what we're gonna do today. It's all about just how to deal with different supports shapes and how you change it to uh, how you change it when you make the free body diagram. Okay, the first one, which is really common, the spring or the rope, which is basically if you have any rod that there is any rope or any tension. That's why when you change it to tension, happen to it. It's pretty common in equation in a lot of problems. So anytime you see any spring or any rope that attached to the cable, that attached to the rod, and you need to do the problem is about the rod, you're gonna replace that to the tension when you do a free body diagram. Okay, and this part is not it's not important when you're doing it. It's just like if you do an arrow and you put the tension. Now we know there is a tension in the free body diagram coming from a rope or a spring. Okay. Second one, we kind of talked about it last video more. The smooth surface. Let's say the road is in a smooth surface. So from this shape for of the road, we can tell that the road is falling down to the left. But this one is a smooth surface. That means there's no any reaction. There's no any reaction on the surface. So that basically there is no any forces in the in the x direction. Only forces that we have is in the y direction, and it forces normal to support in the surface. It is only on the y direction, nothing on the x axis, nothing in the x direction. And if we look at the next one, which is that is the one that I'm talking about, rough surface. This one has a reaction. That means there is a force in the x direction, kind of like has a friction preventing the road to slip easily, as if it was in a smooth surface. So that's why we have, if any time you see a rough surface has a reaction, has a friction, that means there's two forces components, which is ax, one in the x direction, and ay, one in the y direction. Okay. We have pin support. That was also last in the last video, which is really important, coming a lot. Pin support is tied to the ground. Does it have any ruler? Does it have anything? That means has two forces, one on the x direction, preventing the road to go to the left or the right, and the y direction, preventing it to go up or down. So that's why we have two forces in any pin support. On the opposite side, the ruler support, which is also was in the last video example that we had, the ruler support has a ruler. See here, the rules here will make the road can go to this way or this way. That means there's no any forces. There's nothing prevent the road to go to any direction in the x direction. Same thing here for the circle. Uh, just gonna make it move, and this shape and this shape. They're all gonna make it move for the x direction. So nothing, no forces in the x direction, but there is a force prevented, which is this parts prevented to go up, which is that's why we have a force in the normal, which is force in the y direction. Okay, it's very important. Comes a lot in the problems. Ruler supports, pin supports. These two very important. Okay, We have constraint pen or slider. Basically, also the same. You kind of getting the point right now. This three supports kind of also make it freely to the road to go to the in the x direction, right or left. So that means there's no any forces on the x direction. That means we only have only one force, which is in the y direction, which is this one is prevented to go up. So that's why we have only one force going to the in the y direction. Okay, this one also is very important and it's common a lot in the equations. Fixed support. Fixed support, that means this road is attached to the wall. That means cannot go up or down, cannot go right or left, and also has a moment. Anytime you see this pin, you have force in the x direction, force in the y direction. You have a moment anti-clockwise. Why is anti-clockwise? Because basically the weight mostly basically going to this way. So if you use your right hand rule, it's gonna go for anti-clockwise. That's why the moment is going for this direction. Okay, and that's it. Thank you so much for watching. I say that's a quick video, and have a good day.